Okay, well, first of all, welcome. Today, me, Samuel Andres Guerrero Morales, and my partner Israel Peralta Valderas will be explaining what is a trigonometric function and how to solve them. I hope you like our video and our explanation is clear. So, without saying anything else, let's get started. Okay, so before we start to know how to solve a trigonometric function, we first have to know what is it. Well, a trigonometric function, in simple words, is one of many functions that relate one non-right angle of a right triangle to the radio of two lengths of any two sides of the triangle or vice versa. Okay, well, before we proceed to see the parts of a right triangle, we first have to know some few things. Well, first of all, a trigonometric function is represented with this little symbol, which is like an F. And also, any trigonometrical function always satisfies either of these following equations, where this little symbol, which is like a zero, is the measure of a certain angle in the triangle, and A and B are the lengths of two specific sides. Okay, well, now we pass to see the parts of a triangle. Well, first of all, the leader angle is the acute angle that indicates who the categories of the triangle are. Also, the adjacent angle, it is the side beside the hypotenuse that makes the leader angle. The opposite categories, it is the side of the triangle that is located across the angle of reference. And the hypotenuse, it is the longest side of the triangle. And as you can see, each of these one is represented by a little symbol. In this case, the leader angle is represented by like a little zero, but with a line across. The adjacent categories with a little letter A, the opposite categories with a letter B, and the hypotenuse with a letter C. And as we can see, we have a little reference of here, like of a right triangle, and we can see the place of each one in the triangle that it's going to be. Also, we have to know some things, that there can be different cases in which this leader angle can be in this part. So in this case, we have to switch these two, because we know that the adjacent categories has to be beside the leader angle. Okay, well, now that we know what each letter or symbol stands for, we can now see the trigonometric functions for the leader angle. As you can see, sin is equal to sin by the leader angle, it's equal to b over c. Cosine is equal to cos by the leader angle, it's equal to a over c. Tangent is equal to tan by the leader angle, it's equal to b over a. Cotangent is equal to cot by the leader angle, it's equal to a over c. Secant is equal to sec by the leader angle, it's equal to c over a. And cosecant is equal to c sc by the leader angle, it's equal to c over b. And just for a little tip so that you remember each of these ones, if you memorize the first three, you already have it, because what you can do is, as you note, each of these ones are the same but backwards. So as you can see, by just switching them, we can know all six. As you can see, sin is equal to sin by the leader angle b over c. But cosecant is equal to to c as c by the leader angle is equal to c over b. So we just have to switch the letters and we already know the six of them. Okay, well, now that we know this information, we can now do an example. Okay, first of all, we can see that we have, in this triangle, we have the leader angle over here. So as we already know, the adjacent categories has to be right beside him, the leader angle. And the opposite categories will be over here. And also we can see that we already have the letter B and the letter C, but we don't have the letter A. So meanwhile, we can start filling, the trigonometric functions that only use the letter B or the letter C. Okay, so we can now start filling. Sin use B and C, so it will be 5 over 15. Cos AC, so we only fill C. Tan BA, so it will be 5 over here. Cot AB, 5 over here. Okay, 15 and 15 and 5. So now that we fill the trigonometric functions that has the information that we already have, we have to pass and find the information that we're missing. So in the case that we are missing any information, well, we have to use these fractions over here, or better, these formulas. And well, in this case, we have to find a. So now, okay, so we have to substitute. It will be a squared equals c squared. In this case is 15. 15 squared minus 5 squared. Okay, a squared equals 2. We already know that 15 squared is 225 minus 25. It will be a squared equals 200. But in this case, we have 200, well, a squared equals 200, but we want to know what is a. So in this case, we will add a square root so that it cancels the square. Okay. So in this case, it cancels, and it will be a, it's equal to the square root of 200. But we have to check if this gives us a complete number, because if that is the case, we can simplify it more. But in this case, it doesn't, it gives us decimals, so we just leave it like that. And we add this information to the trigonometric functions that are missing information. Okay, and once we have this, we are already finished. And well, this will be the answers for the first case. Okay, well, next we can do another example. Well, in this case, we don't have the letters, or we don't have which of these ones represent what number. So, but we do have the leader angle, and by only having the leader angle, we can already know what letter represents each number. So remember that the leader angle has always beside him the adjacent cathedus. So 6 in this case will be letter A, and letter B will be here, because it has to be all the way on the other side of the leader angle. And well, the largest side, it's going to be letter C. So in this case, we only have to annotate, well, the information that we already have. So it will be BC, it will be 8 over 10. AC, it will be 6 over 10. BA, it will be 8 over 6. Good, it will be AB, it will be 6 over 8. AC, 6, 10. And it will be 10, like that. Okay, well, in this case it will be all, since we already have the values. We only had to know, or we only had to find which of these numbers represent what letter. So yeah, this will be the answers.
Hello, my name is Israel, and today I'm going to show you how to find the trigonometric function with any given angle. So, we know that these are the trigonometric functions, and to get them, we need to have the leader angle, which is theta. Now, if I give you, for example, a given angle like 25, now we can use this angle and use our calculator to find any. So here I will have 25, 25, 25, and here we'll have 25, 25, 25, 25, 25, and 25. When I have this, I can take my calculator, check that it is in dec and not radians, and I can use sin 25 and we'll get me the answer. So now I know that sin 25 gets you 0.4 4, 22. Now I do the same with cos. It will give me 0.906, and with tangent 0.466. So that's how you use it. But how do we get cot, sec, and CC if I don't have them in the calculator? Pretty simple. I divide. For getting cot, I divide 1 by tangent 25. I can either put it like 1 divided by 0.466, because I already know that tangent 25 is 0.466, or I can put it in the calculator, 1 divided by tangent 25. It will give me the same, 2.144. Then for sec, I use cos. 1 divided by 25, 1.103. And for CSC, I use sin. 1 divided by sin 25, 2.366. And that's how you get the trigonometric functions with any given angle, since it is the leader angle. And just remember for your calculator to be in dec and not in radians. Dec, not radians. Okay? That's all for this. Now I'm going to do some exercise for you to get better the idea. Hi, now I'm going to do 2 exercises about finding the trigonometric function with any given angle. So imagine we have now as a given angle 30. We go to our calculator, check if it is in dec, and it's sin 30. It gives you 0.5. Now cos 30 will give you 0.866, and tangent 30 will give you 0.577. Now here goes the tricky part. For cot, it's not like we have cot in the calculator, so what we do is do a fraction 1 divided by cot is equal to 1 divided by tangent. So now we know that cot is this, so we divide 1 divided by tangent 30, because we know that this is this one. So we know now that here it will be 1.732. For sec is something similar, only that instead of divided by tangent, it's divided by cos. So it would be sec is equal to 1 divided by cos theta. And we know that this one is 30, so it will be 1 divided by cos 30. And we know it is 1.154. And CSC is something similar, only instead of cos or tangent is sin. And we do 1 divided by sin 30, and it will be as simple as 2. I'm sorry. This one is 0.5, not 0.2. So that's the first exercise. Hi again. Now we're going to do a second exercise about finding the trigonometric function with a given angle. Now for given angle we have 45. So we check that, we have 45. Now we check that it is in dec, and we go sin 45, 0.707, cos 45, cos 45, it gets to the same 0.0707. For tangent 45, we have 1. For cot, we know that we do the division of 1 by tangent, like this, 1 divided by tangent. We know this is 45, so this is 1 divided by tangent 45. It gives us 1. Sec, you use cos, so it will be 1 divided by cos. The angle given is 45, so it will be 1 divided by cos 45. 1.414. And for CSC is sin theta. So there is 45, and we already know. 1 divided by sin 45. And it's the same, 4141. That will be all for finding the trigonometric functions with any given angle. Thank you. Bye. Hi. So now I'm gonna do an exercise about finding the trigonometric function with any given angle, only that it will be changed, because here they don't give us the angle, they give us the numbers of the sides of the triangle, and we need to get the trigonometric function. To solve this is pretty easy. We only need to take two things into account. This is a little chart that we already know of the fractions, and how to get each of the sides. This we already know it. Now, to solve it is pretty easy. First, we know that sin is b, and it's b divided by c. So we know that 5 will be b, and that 7 will be c. Now we can solve some of these with this information. Now we know that sin will be 7 by 5, cos will be a, that we don't know, by c, which is 7. Tangent is b and a, but we don't have a, so we just b 5 by something. Cot will be a divided by b. We still don't have a, so we just b will be 5. Sec will be 7 by something, and CSC is c by 5, c by b, and it will be 7 by 5. Now, as you can see, we have some that we couldn't fill. These are the ones that have a. Now, to get a, we use these equations. So it will be as simple as using this one, because we need a, and it will be a quadratic equals c quadratic minus b quadratic. B quadratic is equal to c. We know that c7, so it will be 7 quadratic minus b, which is 5 quadratic. A equals 7 times 7, 49. 5 times 5, 25. The quadratic will be 49 minus 25 is 24. Only that with this, we only know that 8 times 8 is equal to 24. To solve this even further, we use the square root. Now we know that a equals, only that the square root 24 isn't exact. So as we want an exact answer, we leave it like square root of 24, and we only fill where that a belongs. 24, the square root of 24, square root of 24, square root of 24, and that's all. Now, as you can see, it was pretty easy and simple to get this, since this will be our answer. Hi, now we're going to do another exercise about finding the trigonometric function with any given angle, only that since they don't give us the angle, they give us the number of the sides. To solve this, we need this table and these operations that we have already know. Now, we know the tangent is b over a, so now we know that b is equal to 9 and a is equal to 4. Now, with this, we can already solve some of the exercise and some part of a part of the exercise. Since sin is b over 6, so we know that it's 9 over c, we don't know which c is. A will be 4 over something, we don't know which it is. B over 8 will be 9 over 4. Cot will be 4 over 9. Sec will be something divided by 4. And CSC will be something divided by 5. Now we're missing C, and that's why we cannot yet solve this problem. So here is where these operations come. We need to get C, so we choose this operation will be C quadratic equals A quadratic plus B quadratic, which will be correct. It's equal to A we know is 4, so it will be 4 quadratic, plus B we know is 9 quadratic, so we will know that it will be 4 times 4, 16, plus 9 times 9, 81. C quadratic will be equal to 16 plus 81. 16 plus 81 is equal to 97. But we only know that C times C is equal to 97. We want to know which one C is, so we just square root, and then C is equal to the square root of 97. Since it is not exact, and we want it exact, we leave it like a square root of 97. So now we know that it will be b, or 9 divided by the square root of 97, square root of 97, square root of 97, and the square root of 97. So now, just like that, we have all the complete answer. We'll leave it like a square root for it to be exact, and that's all. Hello. So now we're going to find an angle in a right triangle with any of its two sides. So we can find this angle with any of these sizes. We only need two. For this, we know that. So for example, I'm going to use sin. You can use any trigonometric function that you want. I know that sin is b divided by c. Now, in this case, since this side is closer to the other angle, we know that A is 3. And since this one is the hypotenuse and the longer one, C is 5, which led us to know that B is 4. Now, in this, we know that sin theta will be 4 divided by 5. But we do not want to know sin theta. We only want to know sin. So what we do is we only want to know, the angle. So we change it and we put sin minus 1, 4 over 5. Now this looks a little complicated, but thanks to God we have our calculator. We only change it to sin minus 1, 4 divided by 5. And it should give us the answer, which in this case is theta equal to 53.13 angles. And now we know that this one is that theta is 53.13 degrees. And we can then know this angle, but here is until we will get it. Now I'm gonna show you another two exercises as an example and as practice. Thank you. Hi. Now this is our first exercise of getting two sides of a right triangle and get to get the leader angle. Now, here, since this side is closer to the leader angle, we therefore know that 10 is A. And since this one is the largest and the hypotenuse, 15 is C. Now, we do not need B, because with A and C, we know that the trigonometric function that uses A and C is cos. Now with the sinus, we do AC, so it will be cos equals 10 divided by 15, right? We already know that. Sorry, we already know that. So we already know that cosinus will be 8 divided by 6, so 10 divided by 15. So that this will be cosinus theta, and we only want the theta, we do not want the cosinus. So we change it off side, and now it is cosinus minus 1, 10 divided by 15. We go to our calculator, we click on cosinus minus 1, 10 divided by 15, and we know already that the theta angle will be 48.80 degrees. So this one will be this. And that's how you solve it. Now I'm gonna solve another triangle. So here we go. Hi. So now I have a second exercise about finding an angle of a right triangle within its two sides. Now the sides we're giving something are these ones. So first we need to classify them. I know that this side is the one that is the most far away from the leader angle, so this one will be B. And this is the longest, so it's the hypotenuse, or also called side C. Now the trigonometric function that uses B and C is sine. So now I know sine is B over C, sine theta, so sin theta is equal to 12/56. But this formula only gives us sin theta, and I only want sin. I only want the leader angle, so I change sin outside, change the number to negative, and now I use my calculator to do sin minus 1, 12 divided by 26, and I know that it will be 27.48 degrees. And so this one is 27.48 degrees. So it is as simple as this. This is all for this topic.
We're going to see converting degrees to radians and vice versa. Well, first of all, we have to know what is a radian. Well, we can say that radian is a measure of an angle that, when drawn as a central angle of a circle, intercepts an arc whose length is equal to the length of the radius of the circle. Very important, we always have to remember this formula, because with this we're going to be finding the answers to the next problems. Okay, well, next we're going to see what we have to do when we have radians, but we have to pass it to degrees. Well, in this case we have to use a different formula, but it's also easy. In this formula, well, the x, which is the radians, is going to be multiplied by 180, but divided by pi radians. Well, in this case, the radians cancel because it's dividing, and it will only divide by pi. So in this case, it will be 2.5 times 180 over pi. And we can do the next one at the same time by 180 over pi. So now we go to the calculator, and it will be 2.5 by 180, it will be 450 divided by pi, which is This equals to 143.23. And this is going to be the answer for the first one. And let's see the next one. Oh, sorry. Okay, there you can see it. It will be 90 by 180. In this case, it will be 16,200 over pi. And this will be 5,156.62. And that's all. That are the answers for these problems. And as you can see, it's very simple and it doesn't need a lot of procedure or anything. So yeah, this will be the answers for the problems of radians degrees. Okay, well, now that we know what is a radian, we can pass and do an exercise. Okay, well, first of all, we have to know that to find the radian from the degrees, we have to use the formula, which is very simple. We only have to use the rule of 3 simple, in which case the x in here will be the degree. It will be 15 times pi. It's equal to 1 rad over, we don't know yet, but this one over 180. So in this case, we only have to multiply 15 times 1 divided by 180. So it will be 15 divided by 180. It will be 1 over 12. So in here, we just put it as 1 over 12. But this is not finished yet. In this case, we have to put the answer as a certain thing. In this case, well, it will be 1 over 12, so it will be 1 over 12 by pi rad. And now this will be the correct final answer. Okay, if it isn't clear yet, well, we can do another one so it can be a little bit more easy. Okay, it is the same, really. Well, this one when you are doing degrees to radians. So it will be 60 by pi by rad over 180. It's equal to 1 pi rad over something that we don't know yet. In this case, well, it will be 60 times 1, it will be 60, divided by 180, and it will be 1 over 3. But as we already know, this doesn't stay as this. We have to put it as 1 over 3 times pi rad. And now we will have the correct answer for both. And as you can see, it is very simple, and this will be the answers for these problems.
Hi, now the next topic is common angles. There are some angles that we use in trigonometric functions which are the most common. 0, 30, 35, 60, and 90 are those angles. Now we're going to fill this table that has a trigonometric function of each angle, but solving it with any calculator. So if we are in any case that we need the trigonometric function of any of these angles, we can do them without the need of a calculator. Now, sine. This is really easy. For sine, it will be the square root of 1 divided by 2 for 0. Then the square root of 2 divided by 2 for 30. Square root of 3 divided, sorry. It's not like it is, sorry. The square root of 0 divided by 2 for 0. Square root of 1 divided by 2 for 30. square root of 2 divided by 2, 45, square root of 3 divided by 2 for 60, and square root of 4 divided by 2 of 9. As we know, 0 divided by any number is 0. The square root of 1 is 1 divided by 2. It has no solution, since we will need a calculator to know each of these square roots. And the square root of 4 is 2 divided by 2 is equal to 1. Now, for cosine, what we'll do is for 0, square root of 4 divided by 2, for 30, square root of 3 divided by 2, for 45, square root of 2 divided by 2, and for 60, square root of 1 divided by 2, and for 90, square root of 0 divided by 2. Now, this is as easy as we already did here, so we already know it's 1. These two have no solution to be exact without the need of a calculator. This one is 1.5, as we already saw here, and 0 divided by any number is still 0. Now, for tangent, what we do is that for tangent, what we do is that we divide the result of sine divided by result of cosine. So here, this one will be 0 divided by 1. This will be 1.5 divided by the square root of 3. This will be 1 divided by 2 divided by the square root of 3 divided by 2. This is 2. This one will be the square root of 2 divided by 2 divided by the square root of 2 divided by 2. Then this one will be the square root of 3 divided by 2 divided by the square root of 1 divided by 2. This will be 1 divided by 0. Now, as we already know, 0 divided by any number is 0. You cancel the 2's, and now you have 1 divided by the square root of 3. For this one, it's as simple as 1. Since you are dividing the same by the same. Here, you cancel the 2's, now you have the square root of 3 divided by 1, which is the square root of 3. And any number divided by 0 is infinite. Now you have the top 3. Now for the bottom 3, this is pretty easy. For cotangent is the fraction of tangent in the other side around. So it will be 1 divided by 0. The square root of 3 divided by 2 divided by 1 divided by 2. It's the same, since we are dividing the square root of 2 by 2 by the square root of 2 by 2. This will be the square root of 1 divided by 2 divided by the square root of 3 divided by 2. This will be 0 divided by 1. Now, as we already saw here, any number divided by 0 will give you infinite. Here, you cancel the zeros as we did over here, and you will have the square root of 3 divided by 1, which is the square root of 3. Here it is still the same, since it's 1, and these two are equal. You cancel the 2's, and now you have the square root of 1 divided by 3. And 0 divided by 1, as we already know, 0 divided by any number will give you 0. Now, sec. What you do is what you did in cot with the tangent, as switching the tangent, but with cosine. So you switch cosine, which will give you 2 divided by the square root of 4, 2 divided by the square root of 3, 2 divided by the square root of 2, 1 divided by the square root of 2, and 2 divided by the square root of 0. Now, to solve this, you do the following. So what you do, it will be 1, the square root of 4 is 2, sorry, is 2, square root of 2 is 1. This, you cannot solve it without a calculator. For this one, the square root of 1 is 1, so here it will be a half. So just, oh sorry, here is here these two are the other side. Around it will be 2 divided by the square root of 2. Sorry, divided by the square root of 1. And this is 2 divided by the square root of 0. This, any number divided by 0 is infinite. And this one will be 2 divided by the square root of 1, which is 1, which will give you 2. Now, for CCH, what would you do is the following. So this, you do something similar as with cotangent and sec, only that with sine. So it will give you 2 divided by the square root of 0, 2 divided by the square root of 1, 2 divided by the square root of 2, 2 divided by the square root of 3, and 2 divided by the square root of 4. And the number divided by 0 is infinite. 2 divided by the square root of 1, as we have here, it's equal to 2. This cannot be solved as of these ones without a calculator, and this will be as simple as 2 divided by 2 is equal to 1. So now, that's how to get this table solved. As you can see, these are the only ones that cannot be solved without a calculator. But apart from that, you already have everything that you need. That will be all for this topic as trigonometric function and common angles. Bye.
Okay, well, the next thing we're going to see is special right triangles. Well, in this topic, we have to be aware of two triangles. First of all, this one that has 90 degrees, 45 and 45. In this type of triangle, the bottom side is going to stay as it is. Or well, depending on the information that they are giving us, we're going to do certain things. But as well as the other side, these two are going to stay the same. In this side, in the hypotenuse, we're going to multiply the x by the square root of 2. Okay, on the next one, it's the triangle of 90 degrees, 60 degrees, and 30 degrees. In this triangle, the bottom part is going to be as it is. The hypotenuse is going to be multiplied by 2. But this side over here, it's going to be multiplied by the square root of 3. It might look a little bit difficult or confused when you're seeing it, but once you're doing the problems, it's going to be really easy. So without saying anything else, let's move on to the problems. Now that we know what each special triangle needs to do so that we can get their sides, we can do an exercise. So in this case, we can see that these two triangles are the same, only that this is upwards and this is backwards. So in this case, this side will be this side. Don't let you confuse because this number looks a lot like this, but it's not, it's just the side. So in this case, x is going to be 2 times the square root. Okay, so we already know that the x goes in both places, so it will be also 2 by the square root of 2 in this place. And on the other side that we're missing, we have to multiply the x, that it will be 2 by the square root of 2 by the square root of 2. So in this case, well, it will be the square root cubic because we have 2, and these two cancel. So at the end we will have 2 by 2 and equals 4. As you can see, once you have one character of the triangle, it's very easy to get the answer. And it might look a little bit confusing, But once you understand it, it's very easy. And well, let's go to another exercise, but of the other special triangle. Okay, well, now we have an example, but of the other special triangle. Well, as you can see, these two are the same, and well, it's a little bit to the other side, but this side will be this side, will be this side, this will be this one, and this will be that one. So in this case, we know that that x is going to be 8. Okay, do you see? Yes. Okay, so to get the hypotenuse, we have to multiply x by 2. So in this case, we will just do, well, 2x is equal to 16. So this side will be 16. And in the other side, in this one, well, we have to multiply x by the square root of 3. So really, in these cases, we just have to put the number. So we just have to put the number and by the square root of 3. Because if we do this operation, well, we will get a lot of decimals and we might get confused. So in these cases that you don't have, well, that you have to leave it as a square root, well, it's okay to leave it like that. So in this case, this will be the final answer. It's very simple. You just have to memorize these, well, each of the triangles and how to solve them. But once you have one side, it's very easy to get the other ones. So I think we're going to the next theme. Thanks. Okay, before we go to the next topic, we first are going to do a word problem that my friend Israel is going to put over here so that you can see it while I'm writing it. Okay, first of all, we have to read it. You fly a kite tied with 20 meters of string, and the kite forms a 29 angle from the ground. How high the kite is flying? Okay, first of all, we have to write the data that we already know. In this case, it will be, and we know that the string is 20 meters. So 20 meters, and we know that the leader angle is 29 degrees. Okay, so next, what we can do is we can draw it so that we can have a better idea of what we're talking about. So imagine that this little drawing is you, and you're flying a kite like this. Okay, this is the ground. This is the string of the kite. This is 20 meters. This is the 29 degrees, and here is the kite that you are flying. Okay, you find it. But what they are asking us to find is this, which is the height. Okay, so what we can do in here? Well, what we can do is apply the trigonometric function of sin, because what we are asking for is the letter b, that is right here, and we have the letter c. And sin is the trigonometric function that uses both of them. So in this case, we try to find b. So we reverse it so that we can find b, and it will be something like this. By the leader angle, which is 29, by c, which is 20, like this. And once we multiply everything, we will get 9.69 meters of height. We check it, and it will be sin times 29 times 20. 6.69. Okay, and that's how we solve, well, this problem. Okay, I think that it's very easy, but for you to understand better, I recommend you to draw it so that you can know what you're talking about. Okay, so let's move on to the next problems. Okay, well, another thing that we have to see is the laws of sines and cosines. Well, first of all, we have to know that the laws of sines establish a relationship between the angles of a triangle and the sides A, B, and C. Also, the laws of sines and cosines can be used in any type of triangles. It can be a right or a non-right triangle. And also, another important relationship is the loss of cosines, which is this one right here. And with this known, we can move to the exercise. Okay, so now that we know how to do this problem, well, we can see the triangle. In this case, well, we already are given the letter A. Also, the letters are always across the other side. So, for example, if I have the letter C here, the other letter C is going to be here. If I have the letter A here, the other letter A is going to be here. And the B here, the other is going to be here. Okay, so we are already given the letter A. And we know that A over C, A is equal to B over C, B is equal to C over sin 6. So what we have to do now is replace this and isolate the variable that we're looking for. In this case, we're looking for B and C. So I'm going to do first B. In this case, it will be A over sin A. It's going to be B over sin B, which is the same as B. It's equal to A. In this case, it's 15 times sin B, in this case, is 28. All this over sin A, which is sin by 92. And once we have already written the operation, well, we have to pass it to the calculator. Okay, so we could 15 times sin 28 divided by sin 92. And it will give us, okay, well, as you can see, I already written the operation, and you can see it gives us 7.04. So B in this case is going to be 7.04. We already know. Let me change it right here. Okay, but we are still missing the letter C, so we're going to do the same but with letter C. In this case, you know that A over C, A is the same as C over sin C. Okay, we already know what A is. It's 15, the same as sin A, which is 92. Okay, and C we're missing still. Okay. Sin C, which is going to be 60. Okay, because we have the C out in here, and okay, we have to isolate the C, so it's going to be 15 times sin 60 divided by sin times 92. Okay, and we have to put this operation on the calculator. Okay, 15 times sin 60, okay, and over sin 92. So as you can see, I already write the operation in the calculator as it is on the board, and we can see it gives us 12.99. So that's what it's going to be, 12.99. Letter C in this case. 12.99. And that's it. We already got the two missing sides with, well, what we already see. And as you can see, it's a little bit long, or, well, you can say a little confusing, but once you understand it, it's very simple, and once you practice it, you will understand it at the 100%. So yeah, I think we finished with this one, and we're moving to a different exercise, but one that it's written. So let's move to it. Okay, so now that we know how to do these kind of problems, we are going to do one, but a word problem in this case. Okay, My friend Israel is going to put the problem right here so that you can see it. And it says, Jack is on one side of a 200-meter wide canyon and Jill is on the other. Jack and Jill can both see the trial guide at an angle of depression of 60 degrees. How far are they from the trial guide? Okay, first of all, we know that Jack is right here and Jill is right here. And they are separated by 200 meters. And they can both see the trail guide right here at the same time. They can both see it. So we can suppose it's something like this, since it is a canyon and they're both seeing at the same time. Okay, in this case, well, I'm going to associate this number to a letter. B is going to be this side and A is going to be this side. Okay, we already know that the angle of depression is 60, so we already have our diagram so that we can solve this problem. Okay, in this case, we will have to use a function that has the angle, well, the angle of depression. It's going to be the angle of C and the letter C. So we're going to use C over sin, well, C, which is the same as 200 over sin 60. Okay, we already have this one, but what we are trying to do is to find the other ones. So in this case, what we are trying to do, well, also we have to notice something. This triangle, well, we already know that a triangle has to have their interior angles have to be 180. And since these distances are the same, we can suppose that it also is 60. So we already have the other two angles of this problem. So in this case, I'm going to find A first. Well, it doesn't matter which one I found first because they are going to be the same. Okay, and C it's equal to 200, and it's equal to sin 60. Okay, and we don't know what A is. Okay. So as you clearly see, at least in this case, we don't have to do a lot of fraction. Since we already have the same angles in here, we can suppose that A is 200. At the same time that B is 200. Well, as you can see in this type of problems, it's very important to see, to express them so that we can see the problem visually. Because in the case that we have them as a word problem is important because maybe we can misunderstood what they are trying to ask us. But well, in this case, these are the correct answers.